In this session, we will talk about stacks. You might have seen various stacks in real life. You might have seen stacks of plates, stacks of copies, and here you can see stack of CDs. If I want to add one more CD to the stack, I can only add it to the top of the stack, like this. And if I want to remove one CD from this stack of CDs, I can only remove it from the top. This is known as stack, in which all the insertions and deletions take place from the top. Thus, stack is also known as LIFO structure. LIFO means last in, first out. That is, whatever item is put in the stack at the end is the first one to be removed from the stack. This application of stack is used in many computer applications. Now let us see how we can implement stack in computers. A stack can be implemented as an array or as a linked list in computers. There are two major operations that are performed in stacks: insertion and deletion. Insertion in the stack is known as push operation and deletion from the stack is known as pop operation. To insert an element or to delete an element from the stack, we always keep track of the top position of the stack because all the operations can be performed only from the top of the stack. So suppose in the beginning I declare a stack of integer array. So this is the stack. Suppose I declare a stack of integer array of size 5. So the structure of my stack will look like this. In the beginning, I will declare a variable top which will keep track of the top position of the stack. As my stack is empty in the beginning, the top will be initialized by the value -1 because the index number of my array always starts from 0. Now when I try to push an element into the stack, I will increment top. So when I try to push 10 in the stack, I will increase the value of top by 1 and top will become 0 and I will push 10 into the stack. So 10 will be pushed in the stack and my top will contain the index number 0, which is the top of the stack. Now to push the next item, suppose 20, I again increase the value of top by 1 and the new value of top will be 1. So when I say push 20, 20 will be pushed here and my top will point to 1 instead of 0. So I can push more and more elements like this, and when my top reaches 4, which is the maximum number of elements that can be inserted in this array, then further push operation will lead to an error and it will display overflow because after that I cannot insert more elements in this stack. Now to remove an element from the stack, I simply subtract 1 from top. I will say top is equal to top minus 1. This will make the value of top to be 0. And now my top will point to this element. Although 20 is still written at the first element position in the array, but it is irrelevant because in the stack we always count an array from 0 till top and whatever is written after that is immaterial. And if I try to delete further one more element from the stack, I will further reduce the value of top by 1. Top is equal to top minus 1 and this will make my top minus 1. It means now my stack is empty. And if I wish to perform another pop operation on the stack, it will result in stack underflow because from the empty stack we cannot delete any more element. So this is how our stack works. And to display the elements of the stack, we always use for loop from top till 0. to display all the elements of the stack. Now let us see a very simple program on the working of the stack in which I created a stack of size 5 of type integer. You can see here, this is a class stack in which we have defined an integer array of size 5 and one more data member is there, which is top, to keep track of the top index number of this array. In the public section of this class, I am declaring a constructor where I am initializing top by the value -1. The other member functions of this class are push, using which I am inserting an element into the stack, and the other one is pop, using which I am deleting an element from the stack, and the last one is display, in which I am displaying the contents of the stack. So I will start from main. First, a stack of size 5 will be created in the memory as given in the class. You can see here, and top will be created for the object S1 of type stack. Now in this loop, I have 4 operations to perform: push, pop, display and exit. Now initially when I will put the choice S1, it will ask me to enter data which I want to push in the stack, and then I will call the push function. In the push function, I will check whether the value of top is equal to size -1 or not, because if it is equal to the size of the stack, then the stack is full and it will tell the stack is full and no more elements can be added to it. If it is not the case, then I am simply incrementing top by 1, which will make my value of top as 0, and I will say add top is equal to item. So whatever item I input using the cin command will be inserted here. Now I come back to the menu part. If I want to pop an item from the stack, it will call the pop function. Now it will check if the value of top is -1, it will display the message stack is empty. It is not the case because the value of top is 0. So it will come to else and it will see out add top, which is 10. And then it will decrement top by 1, which will make top -1. It means this element is deleted from the stack. Similarly, I have a display function which will display my stack from top till 0. All the elements will be displayed one by one. So in this way you can make a program of stack using classes. This is all for the day. Thank you.